What is an AGV steering drive wheel module? An AGV steering drive wheel module is a compact electromechanical assembly that integrates traction and steering functions. The traction system provides the driving force for forward and reverse movement, while the steering system controls wheel orientation to change the traveling direction. Sensing, feedback, and protection mechanisms are integrated into both systems to support precise and reliable operation. Let us begin with the traction system. The drive motor is the primary power source of the traction system. Depending on the module design, an AC induction motor or a low voltage servo motor may be used. Controlled by an external motor drive, the motor generates rotational torque and sends it to the reducer. The encoder is integrated into the drive motor. It measures the motor rotor position and sends feedback signals to the motor drive, allowing the drive to calculate speed and direction for closed-loop speed control. However, the motor normally rotates at high speed and cannot drive the wheel directly with sufficient torque. This is why a reducer is used. It reduces rotational speed and increases output torque before transmitting power to the wheel. In compact AGV wheel modules, planetary gear reducers are widely used because they provide high torque density within limited installation space. As shown in the diagram, the main components include the sun gear, planet gears, planet carrier, and internal ring gear. The following animation shows how these components work together to reduce speed and increase torque.
How does a planetary gear reducer work? A planetary gear reducer is a highly efficient speed reduction device based on the principle of planetary gear transmission. It consists of a sun gear, planet gears, an internal ring gear, and an output shaft. The rotation of the input shaft is transmitted to the planet gears through the sun gear. The planet gears then engage with the internal ring gear to achieve speed reduction. As the planet gears rotate within the ring gear and are connected to the output shaft, the high-speed rotation of the input shaft is converted into a low-speed, high-torque output at the output shaft. This unique design gives planetary gear reducers the advantages of being compact, efficient, and highly stable.
Wheel hubs may be manufactured from ductile iron, alloy steel, aluminum alloy, or other materials, depending on the required load capacity and structural design. Polyurethane and rubber are commonly used as wheel tread materials. Wheel hubs high wear resistance, load capacity, and low rolling resistance, while rubber provides better shock absorption and quieter operation. Depending on the application, wheel diameters may range from approximately 150 to 600 millimeters. The drive motor may also include a spring-applied electromagnetic holding brake. The brake mounting positions in horizontal and vertical steering drive wheel modules are shown in the diagram. When energized, the brake is released and the motor can rotate. When power is removed, spring force engages the brake and holds the motor shaft in position. A suspension mechanism may also be integrated to absorb shocks and maintain stable wheel-to-ground contact. Common designs include spring-guided and dual-guide structures. For heavy-duty modules, multiple damping rods and compression springs may be arranged in a triangular layout for better load stability. Now let us move to the steering system. The slewing bearing supports the wheel module as it rotates around the vertical axis. The steering motor generates the torque required for steering control. In many servo-based systems, an integrated absolute encoder provides position feedback. Based on encoder feedback, transmission ratio, and calibrated mechanical zero, the control system determines the actual steering angle. The steering reducer reduces motor speed and increases output torque, while the steering gear transfers this torque to rotate the wheel module to the required angle. Finally, limit protection prevents excessive rotation. As shown in the diagram, the left and right limit switches detect the steering in positions while the mechanical hard stop provides final physical protection. The following test video demonstrates the left and right limit protection in action.